I'm sharing, but maybe I'll try again. I'll stop sharing my entire screen. All right, can you guys see it now?
Yes, it's coming.
Awesome.
Good.
I
Yep.
see it.
All right, so you guys heard most of that. We're starting our next meeting agenda. This is the agenda that we're going to go through, the schedule for all the different schools, the skills that we're trying to keep up with, programming, CAD, mechanical, and then we're at the update section here. So Lamar is working on things. Bumper brackets were kind of in progress. They put a sample bumper on the drivetrain test bed, and they're just kind of getting a feel. Jem's still working on the CAD on that, which is helpful. Adrian and crew are working on the swerve programming. It's having some issues with rotation, so they're going to get into that more. And then Westside is doing a lot of stuff. Sid is leading the charge. They have a lot of people working on things. Gregory's doing the arms. So yeah, lots of good progress. In terms of Carnegie, I'm not sure where they're at. Maybe we'll get an update from Carnegie later on today to see what they're working on. I know we're talking about an April tag setup, and Les brought a Orange Pi and worked with Adrian to show him how to configure the system and connect to a computer, because we can do all this stuff without the RoboRio. And I think this is a good exercise that Carnegie can do on their own as well. I know Arnav is very versed with Raspberry Pis, so we'll talk about that. In terms of individual roles, I know the t-shirt is progressing. We need to get it ordered. Our documentation is progressing. We have a big presentation for Open Alliance on Tuesday, on the 31st. So we'll put that in there. And then I need to make progress with the procurement and ordering things. I've ordered some things from Rev, Robotics, and from Thrifty. I need to update it all in the spreadsheets so we can keep track of things. I don't know who we want to go first. Samel could talk about the intake if you're ready. Yeah, are you ready, Samel? Do you want to do it first?
I think I'll need 2 minutes. I'm trying to load the CAD.
Okay. Gregory, you want to switch and go first about the ARM?
Sure.
All right. I'll let you take over here.
Let's see.
If you want,
I'm going to start off with the stuff from Slack. So this is the a picture from the EveryBot full manual. Oh yeah, should get everybody up to speed. We're probably gonna build the EveryBot arm, at least just the arm part first, and then we're gonna build around that for the superstructure. We're doing that because right now with the swerve problems, we're not confident that we can get a fully working super complicated custom arm set up and get swerve up at the same time. So yeah, we're just gonna build this EveryBot arm first. So if everything goes to, everything becomes terrible, then we'll always have the EveryBot arm to rely on. So this is some of the critical dimensions that's associated with the EveryBot arm. The main pivot here is probably the main part. And then there's a upper pivot that creates the 4-bar that's connected by a door hinge. And then for the change windows. For the mounting, I've made a concept by myself. So mine is we have two 1x1s, and then this the 2x1 here, and then the idea is we have, because of the lack of availability for the 120-degree gussets, I've tried to use the 135-degree gussets. Hopefully those are in stock. Yeah, some of the things I noticed about the EveryBot was because of the top hinge, that they need a shaft at the back, and a chain running to the main hinge, and because of that, that increases a lot of weight and a bit of complexity. So next step I'm going to try is I'm going to try and move this top hinge down, and see if that's how that will affect some of the things that we have to, some of the movements of the arm. And if I can do that, we can make a shaft here, and hopefully it'll be a lot simpler.
Yeah, in terms of 120-degree gussets, I think we do have some, and we ordered some. But if we really get in a bind, we can always make gussets. So keep that in mind. We have the ability to do certain gussets, and I know you guys already have some custom gussets that you are projecting in the CAD. Those can be machined. It's just we got to make sure they work correctly and not waste time, making really complex gussets if we don't have to. So, but anyway, that's just a aside. Anything else you want to talk about on this? Or?
I don't think so. Oh yeah, we'll be building the main structure of the main arm and intake piece for the Everybot arm at Westside in the coming weeks.
Yeah, I have questions about the diagram that Sid threw up, and I think maybe you guys are working together on it. But this mounting scheme, I guess it's the one on Slack. If you want to just pull the one up in the CAD channel.
I have the CAD pulled up. I can share that.
Okay, yeah, let's just jump straight to that because I think this is very related, and I think it'd be helpful for everyone to understand it.
So this was just like an expansion on Greg's one by one idea. I noticed that we had some more space on one side of the frame so that we could use a 2x1, which I thought, although it is a bit heavier by quite a bit actually, we could add more stability to the structure so it wouldn't wobble as much if it takes a big hit or anything like that.
This just seems a lot bigger, though. I mean, I'm a little confused what we're trying to do here, because it seems like this 2x1 is huge compared to what they have in the original system. Am I misunderstanding side by sides?
If we go to the old Everybot, like
I believe they used the 2x1 also in their original design. It's just when they're using the 2x1, they use the 2x1 on the short side instead of the long side. So that's probably where it's looking like it's bigger. Yeah, there's just more 2x1.
Okay.
All of the main dimensions should be almost the same. Like the pivot should be at basically the same height, but we just flipped the use of the 2x1 and the 1x1.
Okay, and I see you've added.
So what's the benefit of this way over the original A-shaped design?
Well, the original A-shaped design would require the like arm to essentially clip into the swerve modules, and that like it would try and like if you look at the Kitbot chassis, you have space where the swerve modules are on here. Mm-hmm. So essentially, the problem was that it would require us to put like stacked 2x1s. So I think I actually have a version with that in it. Yeah, here. So if we hide the bumper, you can see that they were like stacked 2x1s, and the 2x1 and the 1x1 were getting really, really close to the swerve module, like to the point where there was some clipping even. And I mean, it's a strong like superstructure. It could be optimized because we definitely have space to mess around with, like in the belly pan, which is when we come back to this. If you give it a second, it'll load up. Yeah.
I see it now. So you swap the 1x1, the yellow 1x1 for a 2x1 that's going straight up. Okay, I get it.
But
And
yeah.
you added some extra bracing here, though, it looks like, too, though.
Oh yeah, that's just to make sure it doesn't wobble, and I thought it looked nice. So
It does look pretty solid with the triangles and stuff. So.
Yeah, and just so everyone's aware, I don't know if people see it, but there's some custom gussets in there, which,
Yeah.
will take some machining. It would be nice to think about how to minimize custom gussets if you're kind of designing your own webbing. So you
Mhm.
probably could look at some of the Vex Pro angle gussets that we might already have that
Okay.
fit the right angles, since you get to kind of play with the angle. It just saves us a little bit of time of machining
Yeah.
stuff.
We could like laser print them in something and then use them as templates too. So if we need to, just put a wood template.
Yeah, there's
Yeah.
lots of ways we can make it. Just think about how to minimize the effort if
Yeah.
necessary. Some of
Mhm.
it is just not going to be possible because there's different angles that won't even match with what we can buy.
I will say that all of these are at 45-degree angles together. Also, like the gussets, I designed this for use with like Rev Spark tube, like Max Tube, just because it already has the holes drilled in the sides compared to VersaTube where you'd have to go and drill every hole. So that's the reasoning behind this. And then also this hole patterns on the gussets should coincide with Max Tube. This last one I have to fix, but all of these gussets, they line up perfectly with the Max Tube hole pattern, which seems pretty solid.
Yeah,
You can-
in the rev order that I made, I have to check the dimensions, but I think they only had like 40 something inches available.
Mhm.
So I don't know if that's going to fit what we have here.
I think 48, I think, is the rev.
They
Yeah.
don't sell, I guess, this
59.
These are 42-inch ones.
59 inches or whatever.
Yeah, 59 is Vex, but 48 is rev. So
That's 42 right there. So it
Yes.
we're good.
I'll check it.
Okay.
Yeah, I wouldn't get too hung up on the details right now. We can always massage, those final designs. The key thing I want to emphasize though is we got to make sure that geometry matches up with the everybody design. In particular, what I'm talking about is that blue beam that you've got at an angle right now.
Mhm.
You have your pivot point locations. We need to make sure that those match up with everybody, because if we start changing that geometry, then it may not operate and function the same way that they've obviously already demonstrated.
Mm-hmm. Let me check. I'm pretty sure that the height was within like 0.2 or within an inch. So the height is 46.8 inches from the top to the base. And in the actual EveryBot, it's 46.8 flat. So it's basically the same there. And then from the front to the pivot, the EveryBot had it at 6.3 inches, and over here it's 6.18 inches, but it still fits inside the frame perimeter. It's just a little closer.
The next thing I'd like to see is start throwing together Sawmill's intake plates in here and try to get closer to like most of the CAD roughly all together so we can see how it all looks.
Okay. That's project for this week, I guess.
Yeah, I mean, we always want to get as close as we can to a mostly complete CAD. So when we see conflicts, if we need to change something before we start cutting too much stuff, it would save us a lot of time. So Gregory can get hung up a little bit on the details of this mounting scheme to verify everything. And maybe you can move on to just making sure the whole CAD is going all the way.
Sure thing.
So, Sawmill, are you ready?
Yes, sir. I'm ready. Okay. Let me know if it's shown. Can you see the fusion?
Yes.
Excellent. So I'll just be brief here, but last meeting I presented this one, which was some of the intake data from other teams and our own testing that we got. And now this Saturday, we were able to simplify with further research into this type of plate that we laser cut. The main benefits over this in the last one is firstly, it's only like 2 holes, so it was easier to test with and prototype. And if you're wondering how it will intake, basically between the 2 holes in this area is where the tip of the cone will go. So even if the cone is sideways, which we tested, if you run into it with the plate, eventually it will catch the tip of it, and the cone will always be at the end facing so that the tip of the cone is inside and the flange, the part of the square, is directly perpendicular outside. And then if you're wondering how it will take in the cube, no, it does not fit in the front. It will go in from the bottom. So for some background of this design, it was heavily inspired by Team Spectrum's design. And what they have done with this prototype is that, as I said, they take in the cones from the front, but the cubes, it actually goes underneath. So it uses the bumper as a wall, and then it uses this bottommost roller to assist with pushing the cube up, which is what I was able to test on the dummy swerve. And it did work. Now, there's a few rooms for improvement. Firstly, of course, cone intaking can always be more efficient, but it's already pretty good right now. The main thing is about the cubes. What happens is that when you intake it, it kind of stays at the bumper level. And if it was ever a 4-bar linkage and you tried to retract it, it would actually like drop the cube. But of course, since it's a prototype, it will be easy to fix. One of the things might be just adding a 3rd roller somewhere in the middle so that it can continue pushing that cube up. Because currently it just gets stuck at the 1st roller since there's no other boost going to it. So like this curve right here, it represents the radius of the bumper. And that's how when the linkage will come down, basically it starts inside the robot first and the linkage has to come down. At position 1, it's all the way in within the frame perimeter. Position 2, it will be only a little bit out and the bumper will be touching on this curve so that it can intake cube. And position 3, it's all the way on the floor. Like this line will actually be the floor. This line is exactly rubbing on the floor as of right now. And that's how it intakes the cones. So hopefully the next steps will be putting more geometry in the correct position so that we can get the cubes fully up. And then maybe like my ideal thing would be that we don't actually need 3 different positions and we can always intake cubes and cones regardless in just the same place. And that's most of the updates for the cone, for the ground intake. But it did work very well. I know I made it sound a bit disappointing, but
I have a
I think it was good
question.
results.
I have
sorry?
a question. I have a question. After your position 2, when it hits the bumper, how will it go further down to the ground? Like, wouldn't 2 be the final position of the, like?
Yeah. So the 4-bar linkage it's not like parallel moving. If you imagine this is the intake as it's shown, right here on this hole, there's 1 bar that's going down, and right here there's another one. This bar that's going down is much longer. So it actually moves in kind of an arc. So as it goes on the bumper with this curve, when that bar keeps moving more, it actually pushes the intake more out. So that's also one of the rooms for improvement. Glad that you mentioned that. Also, one of the room for improvement is trying to get it as much compact in the robot as possible. Because currently, since this moves out in an arc shape, it does stick out quite far if it was on a real robot.
Yeah, and eventually we need to, I guess, take some of those prototype videos and share them so everybody can kind of watch them over and over again and see how things are going.
Mm-hmm.
We don't have great videos yet of things picking up cubes, but I think we can get some more this week and really study it and make sure that the prototype is working the way we expect it to. So.
Yeah, talking about videos also, if anyone has a picture, video, or other tidbit of information that they really want to put on the Open Alliance Chief Delphi, then let me know and I can paste it in there.
Yeah. So I have a question. So Spectrum is actually intaking the cube through the two rollers. So
Correct.
Which
Yeah, so that's what I realized was their later prototype design. This was their more initial one. And we first, like, basically what we were discussing is first we want to make it very basic, where we can just intake from the floor and score on the floor as well. So this is the most like elementary basic design, so that we can get to know how the compression works and how everything should go out. Now from there, we could go into more advanced or more complex design like this, where it will always intake through the tube and it will always,
Yeah,
get the robot.
I think they just had a smaller rod on the bottom. I think they kept the big rod, the bigger wheel on the top. But anyway, it might be able to do it if you look at the
Yeah,
more
it's
recent
very
videos.
likely we might be able to make this, just have the cube go straight in between the
Yeah.
two wheels. We just
You're
have
pretty close. You might be a half an inch off.
but
I
keep
mean,
in
no,
mind,
wait, no. According to their CAD, like the gap in between just these two centers is 3 to 4 inches, and a cube is 9 inches wide. So it's definitely a different CAD that they're using.
Okay, yeah, I guess so. I just see it go on the TV, on the video, so it's like, oh, that worked.
Yeah.
another thing to keep in mind is Spectrum posted that they've popped 4 or 5 cubes.
Okay,
So we probably should be a little careful since we don't have a lot of cubes.
that's right.